In this video, I am going to show you how to design a PCB for your designed circuit. I hope you have already watched the introductory video where Dr. Cox talks about some very basic concepts in PCB design. If you have not watched that video yet, please watch that video first. Alright, I want to design a 5-volt supply for my microcontroller and other low voltage devices, but I have a supply that gives me 12-volt output. So I'm going to use a voltage regulator to convert that 12-volt supply to 5-volt. To do that, I'm going to use a device named LM7805. This is the datasheet of LM7805 from Texas Instruments. Here we can see this device comes in 4 different packages. For our circuit, we are going to use this package. This is a standard package called TO220. In most cases, datasheets provide example circuit for that device. Here we can see TI has provided an example circuit for fixed output voltage regulator. We are going to use exactly this circuit with input and output connectors. The first step for the PCB design is to capture the circuit in schematics. So we have to open Orcad capture. You may find this as design entry CIS in your computer. We have two options here. Allegro PCB library and Excel is basically for designing libraries. We will not use that. We are going to use PCB design CIS L. So this is how the homepage looks. It might be different in your computer if you are using a different version. First of all, we have to create a new project. Go to File, New, Project. Select Schematic Project. Select the folder where you want to save your files. I'm going to save my files in the Documents folder. I have already created a folder named Orcad. Give a name. Select OK. This is our project folder. So you have the schematic files here. You can have multiple pages. It has automatically created one page, and that page is page 1. We have to place the components. To place the components and wires, we need the drawing toolbar. The drawing toolbar is this one. If you can't see this toolbar in your computer, you can find this toolbar from View, Toolbar, and Draw. I'm deselecting this, so the drawing toolbar is gone. Let's get it back. Toolbar, Draw. Okay. To place the component, click this Place Part icon. A window will pop up like this. These are all the libraries I have in my computer. If you don't see the libraries here, you can add the libraries from here. Select all and open all the libraries, so it will add all the libraries to your design folder. Okay, now let's look for LM7805. You know we are going to use TO220 package. So this is what we are looking for, LM7805C/TO220. Hit enter and left click to place the part. right click to end placing the component. If you remember, we have seen in the datasheet that LM7805 has 3 pins. This model also has 3 pins, but it has 1 pin hidden. We can make the hidden pin visible by right clicking and edit part. So this is the pin that is hidden. Double click, change the shape to line and select this checkbox, pin visible. Click OK. Okay, we can move this around. Okay, and now close this window, hit update current, so you can see 3 pins here. Yeah, we need 2 capacitors, one for input and one for output. Right click, end mode. We need connectors for input and output voltages. So let's find connector 2 that has 2 pins. If you want to rotate the component, you can press R. It will rotate the component 90 degree. Each time you click R, click end mode. Okay, you can move the components by clicking left mouse button and dragging the component wherever you want. To connect the points, we need wires. We can place wires from place wire, or we can just press W and start wiring our schematics. Okay. End wire. Schematic is almost ready. We have to set the capacitor value here. You can set the value. So we can set 1 microfarad here and 1 microfarad for these as well. To export the schematic file into our PCB design software, we need to create Netlist. Netlist is sort of a file that contains information about how many nodes we have in the design and how the nodes are connected to each other. But before creating the netlist, we have to define the footprints of all of these components. We already know that the footprint for this LM7805 is TO220. Let's find out the footprint of these capacitors. I'm going to mouser.com and I will search for capacitor. Let's select 1 microfarad. So these are the capacitors. If we look through this list, we can find the footprint for the capacitor. So this is the footprint for this capacitor. This is a very small footprint. We are going to use this one. So the footprint name is 0805. This is very standard footprint. We are going to use this kind of headers for our input and output. Now our schematic file is ready. we have to create a netlist to export the information into our PCB design software. But before doing that, we have to define all the footprints for these components. To define the footprints, select all the components by clicking Ctrl and A, and by clicking Ctrl and E we can bring out this property editor window. Select this parts tab, scroll right to find a column named PCB footprint. This is the column where we have to write the names of the footprint, and here are the reference of the components. Although we know what our footprints are, we don't know how they are written in our PCB design software. So we have to find the footprints in our PCB design software to know the right name. Let's open our PCB design software, PCB editor. Same as schematic, here we have three options. Basically we have two options. This says that Allegro PCB Designer L was performed earlier, and we have another option, Allegro PCB Librarian XL. This is for creating libraries. We will not use this option, so let's select this one. So your default window will be different. This was the project that was open earlier. Create a new project, board file, give a name. Okay, I already have a file named test. I'm going to overwrite that file. Go to place, select manually, go to advanced settings tab, select this checkbox, library, go back to placement list. In this box, select package symbols, and this is the footprint you are going to find in your computer, the footprint for the capacitors. So the name in our PCB design software is 0805 RF underscore WV underscore 12D. We have to write exactly this name into our schematic property editor. Let's write the footprint name 0805 RF underscore WV underscore 12D. Orcad is not case sensitive, so you can write in either lowercase or uppercase letters. Same footprint for the other capacitor. For this connector, we are going to use a footprint called jumper 2. It has 2 pins like this. Let's write the name. Same for the other connector. For the regulator IC, we know the footprint is TO220. Let's find out the right name in our PCB editor software. Scroll down to find something close to TO220. Here we can see that we have multiple TO220 packages. We can select the checkbox to see how it looks. It has 2 pins, but our IC has 3 pins, so this is not the right one. Let's check the next one. This has 3 pins and our IC also has 3 pins. Let's use this footprint. So the name is TO220AB. Let's write the name. Save. go back to our schematics. Now our schematic is ready for converting into PCB layout. First of all, we have to create the netlist. To do that, go to the project folder, select the design file, go to tools, create netlist, select the folder where you want to save your PCB board file. So I'm going to select the same folder where I have saved the schematic files. The default name is same as the schematic file, but you can change it if you want. Select this checkbox, create our PCB editor board. Click OK. Select Allegro PCB Designer L. Select OK. Now the netlist has been created. We have to set up our design rules. First of all, I'm gonna turn the grids on. You can set up some parameters regarding the grid size. I'm gonna leave it default for now. To set up the minimum distance and minimum trace width, go to constraints, select physical. So I am going to set up my minimum line width to 20 mils. I will leave the maximum line width as 0. In this way, we don't have any limit for our maximum line width. And I am not going to change anything of this. I am gonna show you how to select the via you want to use. So if you go down, you can see a lot of vias. I am going to select this via that has outer diameter 50 mils and a 30 mil hole. Double click. I am going to remove the default via by selecting that via and click remove. Click OK. Now our default via is changed to our selected via. Next, we have to set up the minimum distance from trace to trace and trace to pins. So go to spacing tab, select all layers. We are going to set up the same rule for all layers. Select this default, change it to 20 mils. Hit enter. So our default spacing for all class is 20 mils now. Close this window. Now we have to place our components. Go to place, select manually. Select this checkbox to select all the components we have. You can hide this window to place the component. Left click and the components will be placed in our PCB. Okay. Right click and click done. So these are the components we have in our circuit. If I zoom in, I can see that in our capacitor footprint, by default it has 2 traces and 2 vias. I want to delete those. To do so, right click, go to super filter, select C-line segment. C-line means the traces, and select the capacitors. Click this cross button, and now the traces are deleted. In the same way, go to super filter, select via, select this and press this delete button. The vias are also deleted now. Go to super filter and turn off the filter option. Now we have to arrange the components. To move the components, select this icon. Select the component you want to move. If you want to rotate the component, right click while you are moving that component, select rotate, and this way you can rotate the component. Okay. Left click. This is the capacitor connected between these two pins. I'm gonna right click and rotate the capacitor this way. Place it. Move this other capacitor. Place it here. Move the connector. I'm gonna rotate it this way. Move the other connector. I'm gonna rotate it this way. Right click and done. I'm gonna rotate it again. Okay. So our components are arranged in the way we want it. Now we have to draw the traces. To draw the traces, select this Add Connect icon. Select one pin, go towards the other pin and hit enter. This trace is now placed here. I'm gonna connect the capacitor to that pin. I'm gonna connect here. If you place anywhere by mistake, you can select this and you can draw the trace again. You can select points in the line if you want to draw in a particular way. Right click and select done. I want to shift these traces a little bit up. To do that, we can use this toolbar that is called slide. Select it and select the trace you want to slide like this. Okay, I also want to slide this. Okay, right click and select done. Our circuit is so simple that we can do all the wiring in a single layer. But in complex PCBs, we have to use multiple layers, at least 2 layers, to make all the connections. Now I'm going to show you how we can use different layers to connect 2 pins. So I'm going to delete this trace. To do so, select this delete icon, select the trace, right click and click done. Okay. By default, the PCB has 2 layers. So I'm going to start my trace from here, and from here I want to use the bottom layer. So I'm going to click the left mouse button twice and the layer is automatically changed, and you can see the active layer here. So this is the active layer. You can change the active layer to top. I'm going to change it again to bottom, and I'm going to connect it to this pin and right click, done. So by this way, this portion of the trace is on the top layer and this portion of the trace is on the bottom layer. The last thing we need to do is to set up the board outline. To set up the board outline, go to Setup, select Outlines, select Board Outline. Here you can change some parameters. So this says what is the distance from the board edge to the components. Let's set up 20 mils here and draw the board outline. Close this, and our board outline is now set. You can view a 3D image of the board by clicking this 3D viewer icon. This is the PCB we have just designed. Thank you for watching this video. Let me know if you have any questions.